Alright, our calculators have been put away. We now want to find some limits analytically. That means we're going to do it by algebra. They start out really easy. Let's look at this example. The limit as x approaches -3 of 3x plus 2. The first thing you should always try is just plugging in your x value. And this one works. I can plug in -3 for x, and I'll get -9 plus 2 gives me -7. And it really is that easy, you're done. So let's look at another example. This is one with the composite function. See that on C, where we've got g of f of x. But let's go through them one at a time here. On A, it says the limit as x approaches 1 of f of x. So I'm looking at f of x, and I'm just going to plug in 1. 4 minus 1 squared. 4 minus 1 is 3. Done. Going on to part B, the limit as x approaches 3 of g of x. So I'm going to plug in 3, get the square root of 3 plus 1, which is the square root of 4, which is 2. And now here's the point of the problem, the composite function. The limit as x approaches 1 of g of f of x. Now I could go through the hassle of taking f of x and plugging it in to g of x and getting the actual composite function and then finding the limit, but we saw in the notes that there's a really convenient shortcut. What you can do is you can find, oh no, oh, it's just a message from my mother talking about painting a cabinet, ignore that. Okay, what you can do is you can find the limit as x approaches 1 of your inside function, which, by the way, is what we already did in part A. And so that's equal to 3. And then all you have to do is evaluate g of 3. You take your answer and you plug it into your outside function. And so if I plug 3 into that, I'll get 3 plus 1, square root, is 2. Nice convenient shortcut for those types of problems. Alright, the dreaded trig functions. These problems are not bad if you know your unit circle. There's a video in the introduction folder that will review the unit circle for you. All I have to do here is I have to plug in pi. So I've got the cosine of 3 pi. And remember, I don't have a calculator, so I've got to know what I'm doing here. 2 pi is once around the unit circle, so this is the same thing as the cosine of pi, which I know is -1. Okay, go check out that unit circle review if that was hard for you. I want to talk for a second here about zeros. Oh, Mama Schiefer played Mean Words with Friends. I've got to figure out how to turn off notifications. Alright, if I take 0 divided by some number, I know that I'm going to get 0. That's fine. If I have some number and I divide it by 0, I know that that is undefined. But if I have 0 over 0, that's what we call indeterminate. And whenever you're evaluating limits, what I need you to think when you see 0 over 0 is, oh no. When you see 0 over 0, you think, oh no, I've got to do something, and that thing that you're going to do is some algebra before you start working the problem. Okay? So let's take a look at an example. The limit as x approaches 2 of 3x minus 6 over x minus 2. If I plug in 2, I tell you that's the first thing to try. If I plug in 2, it's not just that I get 0 on the denominator, I also get 0 on top. And that's when you think, oh no, and do some algebra. You have some options for the algebra that you can try. My favorite is always factoring. Always look for something that you can factor. And so what I see here is on top, I can factor out a 3, which would leave me with x minus 2 on the top, which would cancel my x minus 2 on the bottom. So I've got a new function here. I can now rewrite this problem to say the limit as x approaches 2 of 3. 3 is just a horizontal line. If I plug 2 into that, I'm still going to get 3, and that's my final answer. So always look for things that you can factor. It goes pretty well. But of course the problems get harder. Let's take a look at this one. The limit as x approaches 0 of the square root of x plus 1 minus 1 over x. If I plug in 0, it's always the first thing we gotta try. I end up with the square root of 1 is 1, minus 1 is 0, over 0. No, I need some algebra to do. Well, I can't factor anything, but what I see is that I can multiply by the conjugate. Here's what I'm gonna do. I'm going to take the square root of x plus 1 minus 1 over x, and I'm going to multiply that by its conjugate, which is the square root of x plus 1 plus 1. If I multiply the top, I also have to multiply the bottom. Now what's the point of doing this? If you think about a difference of squares, let's say I had a squared minus b squared. You know that to factor that, that's going to be a plus b times a minus b. That's your difference of squares. Look at the format that I've got going right here. I have a minus b and a plus b, which means when I multiply those together, I can go backwards. I can go to a squared minus b squared. And stay with me, I promise it's going to help. So when I multiply those out, when I do the square root of x plus 1 times the square root of x plus 1, that just gives me x plus 1. And then 1 squared is going to be 1 over, and I'm not going to bother to distribute the bottom, you'll see why. Okay, so make sure you see that. I took this term and squared it and got x plus 1. I took this term and squared it and got 1. That gives me my form of a squared minus b squared. So I've got a squared minus b squared. And now my 1's cancel out. And I'm left with x over x times the square root of x plus 1 plus 1. And look what happens. The x cancels the x on the bottom, and I am left with 1 over the square root of x plus 1 plus 1. So I can rewrite my limit problem. I'm looking for the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And now this is something that I can plug 0 into and get an answer. So I've got 1 over 1 plus 1, or 1/2. And we're done. Let's do another one. As always, I'm going to try direct substitution first. So I have sine of 2 times 0 is 0 over 0. Go think about my unit circle. Sine of 0 is the y-coordinate, and sure enough, that is indeterminate. So I've got to make sure I go mark out that equals, don't get a linkage error. And so I need to try something else. This sure looks like a special trig limit, but the problem is these don't match. So to fix that, what I really want to do is multiply that by 2. For that to be a legal move, I also have to multiply the top by 2. So what I'm going to do now is I'm going to rewrite this limit where I've multiplied that by 2 over 2, and I'm going to do another trick here where I'm going to let u equal 2x. So the first thing I've done, I've multiplied by 2 over 2, and now I'm going to let u equal 2x. So rewriting my limit, the limit as x approaches 0 of 2 times the sine of u over u. And then I like to just say the limit of as x approaches 0 of sine of u over u is equal to 1. What you're properly doing there is you're pulling this 2 out front of that limit. You're saying this is 2 times the limit as x approaches 0 of the sine of u over u, which we know is a special limit, and so we're saying 2 times 1 equals 2. I don't think it's necessary to say all that. I think you could start right here and say this is equal to 1, and so I have the limit as x approaches 0 of 2, which is equal to 2, and be done with it. One more problem. Make a note of this definition here. You're going to see this again in the next unit. I want to find the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. So first thing I need to do is rewrite my limit for this particular problem, given that f of x is equal to x squared plus 1. So the first thing this is telling me to do is it's saying take this, plug it in everywhere that you see an x in f of x. So instead of x squared, I have x plus delta x. And then don't forget to go back and finish your function. So this was x plus delta x squared plus 1. So that was f of x plus delta x. And then make sure you see it there, minus f of x. That negative needs to be distributed for this whole thing, so I'm going to put some parentheses around it to make sure I go back and distribute that negative all over delta x. Now I could try right now to plug in 0, and I think I would run into trouble. I think it's going to be indeterminate. So the first thing I'm going to do is expand all this on the top. So first I'm going to take this term and FOIL it. So I've got first, outer would be x plus delta x, inner would be x plus delta x, so I have two sets of those. And then last would be delta x squared plus 1, and then I'm going to distribute that negative, minus x squared minus 1, all over delta x. And I'm hoping some things cancel at this point, and they do. X squared minus x squared, 1 minus 1, and let's see what we've got left. So I have 2x delta x plus delta x squared over delta x. And what I notice is there's a delta x in every term, so I can cancel it out. To show that properly, what I'm going to do is on the top, I'm going to factor out a delta x. When I factor that out, I get 2x plus, if I factor out a delta x here, there's still a delta x left over delta x. And then I can properly show those canceling out. And I think I'm ready to rewrite my limit. This is the limit as delta x approaches 0 of 2x plus delta x. And now I'm going to do direct substitution. Notice that this is delta x. That means only delta x gets replaced with 0. So when I do direct substitution, I get 2x plus 0, and that simplifies nicely to 2x. Do a couple of those, and I hope you'll notice some patterns that'll help you going into the next unit.